So today's topic, students, is motion in a straight line. Now, before I start with the actual topic today, let's learn a little bit about the app, the facilities that are available in this app. So the Spark Academy app gives you a lot of facilities for your entire preparation, right? Now, what are the facilities? You get to watch the on demand session, students, whatever topic of your choice, of your doubt, you can just watch that topic selectively in each of the subjects. Then you have live classes available, wherein we teachers take the live classes. And the next thing, students, is about the feedback. You get chapter wise test, full length test, and then you also get to know your grading, average score, and all that. Next thing is you can follow us on Telegram, wherein you can write quizzes, you can clear your doubts. Okay. And then, students, if you like our videos as you watch today, you can also subscribe to our, long-term courses and crash courses, right, students? Okay. So next thing, students, is let us get to our topic now. So today's topic is motion in a straight line. But before starting the topic, student, I'm just giving you a very, very brief introduction of the topic. So, motion is, when you start your study in mechanics, it is, you first learn how to describe motion. So, the most basic characteristics of motion is that it is relative. There is nothing called, a body is at rest or a body is moving. Everything is moving in relation to something else. Therefore, motion is relative. First thing you need to understand is that. Therefore, in physics, first we learn how to describe motion, and then we also study, the cause of change in motion, not the cause of motion, student, because motion can happen anyway. You cannot ascribe the cause of motion to anything, because if a thing is moving with, in a straight line with a definite velocity, then it is moving in relation to something else, and in relation to something else, it might be stationary, right? So, first thing is one, you have to understand that motion is relative. Next things, student, when we start studying motion, there are two aspects to it. First thing is we learn the language that is necessary to describe the motion. Okay, the language of mathematics comes into play over here, and then the second thing is we learn the relationship between the cause and the effect. So the cause is something which Newton discovered, and the effect is the change in motion. So motion is changing from one instant to another, and we ascribe it to a particular cause, and that cause is known by the term force in physics, right? So, force is that physical quantity which is responsible for the cause of change in motion, right, students? Now, we come across in our daily life so many different types of motion that they are so very complicated, and we can't, just we can't begin our study of motion with these complicated types, because then the mathematics would also become complicated. Beginning our study, we are just beginning our study of calculus in mathematics, and we don't have enough tools, we don't have enough methods, so we can't study complicated motion just from the beginning, right? In that fashion, complicated motion, so we start with a very simple motion. So this is the now the relevance of the topic, students. So the thing is, yeah, let us get back to this. So So let us move on to the next slide, students. So this is, yeah, so motion in a straight line. Okay, so as far as path of the moving object is concerned, it can be limited to one dimension or two dimension, or the object is free to move in the entire three-dimensional space. So as far as the path is concerned, students, suppose you are just moving straight, then you are limited to one dimension. You can be moving in a plain road, then it is limited to that plane, two dimension. Or like an aeroplane flying, it moves in the entire space. So it depends, right? Then we begin with one dimensional motion and then we move on to motion in two dimensions. You'll see later on when we discuss projectile motion, when we discuss circular motion, all these are examples of motion in two dimensions. And when you go to three dimensional motion, the mathematics is, it becomes quite complicated. So even in motion in two dimensions, students, we cover only very specific type of motion. So you see, we are dealing with very simple types of motions in one sense. So to describe motion, we introduce the concept of displacement, velocity and acceleration, right? So there is this concept of displacement, velocity and acceleration. We will learn this, and then next we can define them on average basis, that is within a finite time interval, and also on an instantaneous basis as it changes from one instant to another. So we'll see that. And then we need to, primary thing is, students, we need to learn their interrelationship, the relationship, how we define velocity in terms of displacement, acceleration in terms of velocity. So let's see that. Okay, so after this, students, so basically, any general motion requires the help of calculus, but then we also analyze very specific type of motion, that is motion with a constant acceleration. So that you will see, we'll derive the equations, we'll just use those equations. Okay, so let's move on. Then what is the weightage of this chapter as far as your exams are concerned? At least one question, one questions can be asked. Sometimes even that is not asked, but one question you will get it. And the second thing, students, obviously in mechanics, if you want to start your study, you can't proceed on to the next chapter without studying this chapter. And there is another very important point, student, that I would like to make, and that is, when you get questions in other chapters, it already involves the concepts in this chapter. So this knowledge is taken for granted in those questions. So you cannot answer those questions without knowing the knowledge of this chapter. So don't think that you should get an exclusive question from this chapter. You get a question, but sometimes you might not get. And if you don't get, it doesn't mean that the knowledge of this chapter is not essential. It is essential. Okay. So let us move on to the next. What points will be covered in this chapter, students? We will introduce the parameters and then we'll also discuss their interrelationship, and then the most important part, student, is application to problem solving. So let us move on. Now concepts, first thing is displacement. So the thing is, yeah, so displacement, it is the, so this is your start point, this is your end point, this line, directed line segment from start point to end point, that is your displacement vector. Now students, when we discuss motion in a straight line, we will not go into the concept of vectors right now, because see, any motion in a straight line, there are only two directions. Either you can move towards your right or towards your left, and this can be specified without the use of vectors, just by signs. So this displacement is positive, this displacement is negative, right? So one is positive towards the right hand side, positive x-axis, negative x-axis, that's all. So displacement is the amount, of path, you are quantifying that path from the start point to the end point, and that is just a straight line. You don't take into account the actual path. Even if the object is moving along some curve, students, let us say, what is the displacement? Displacement is only this distance, the straight line distance from end point to start point, right? So the concept of displacement must be clear to you, students. First thing is this. Now, this displacement takes place in a given time interval delta t, right? Now, corresponding to this displacement, we have a position. We define position of a particle at a certain instant. So, what I'm trying to say is, students, we have two parameters. One is displacement for a time interval, and one is position for a particular instant of time. These are two different things, okay? Right? The change in position will give you the displacement, right? Again, the straight line. You just have to join the final position and initial position by a straight line, and that will give you the displacement. Next thing, students. So this is the first thing we are concerned in, in motion, to evaluate the displacement or the position at a certain instant. Okay, that is one thing. So the next thing is, we are also interested in the distance traveled by the object. So this is the actual path length. So the distance, you need to find the actual path length over here. Right, students? Now let us quickly move on to the next thing. Next thing, we define velocity. Again, average velocity and instantaneous velocity. These are two different things. Average velocity is for a particular time interval, so you can define average velocity as displacement in that time interval by the amount of time itself. And this is instantaneous, is, any instantaneous parameter, it rests upon the definition of average. How do we define? Using the concept of limit. So as limit delta t tends to 0, students, delta s by delta t is v instantaneous. So basically what you are doing, you are making the time interval to shrink to 0. Okay, so you are getting the average velocity for that, very narrow time interval. And that is the instantaneous velocity, right? So the definition requires the use of calculus then, ds by dt. This notation is ds by dt. Similarly, students, we move on to the next, that is average. So this is for velocity. So velocity takes care of the rate of change of displacement. How, at what speed, the body is moving. How fast it is moving, I'm sorry. Okay, the next you can go on to defining average and instantaneous acceleration. So again, this is for a particular time interval, and this is from instant to instant. So a instantaneous is again dv upon dt, corresponding the same thing, students. So you must know these relations, students. This is very important in problem solving. You must know that, right? So I hope, student, this interrelationship, the use of calculus will be only clear when you do problems, right? So it is not much of a concept over here. You are learning, these definitions, and you need to apply them. Now, if the body is moving with constant velocity, then whatever they have written is, it is for the first half of the journey, it is covering with v1, and second half of the journey with v2, then the average velocity is that. So that you can get it. This is just, I have mentioned it, students. So this is not the general thing. Like this, many points you can get it. So basically, when you study motion in a straight line, there are not many concepts. There are only these handful of concepts, but there is variety of problems. So you need to focus more on problem, students, in this case, right? Let us move on. Now, there is one very important type of motion that we study, students, and that is motion with uniform acceleration. So, in that case, what is dv by dt is equal to a is a constant, right? Is a constant. So, what do you get if you integrate both the sides and put the constant of integration, that is initial at time t equal to 0, u is the initial velocity, you get v is equal to u plus at. And if you integrate this, because this you can write it as ds by dt, you further integrate this, students, and at t equal to 0, s is 0, if you put that condition, you get s is equal to ut plus half at square. So these equations are just got by integration. And if you combine these two and eliminate t, you get v square minus u square is 2as. Right? Is this clear? Now, Sn is the distance traveled in nth second. Right? In nth second. So this also you can get it just by subtracting n s. So it is, nth second. Now be careful. When I write over here Sn, then this is in time n seconds from 0 to n. So this is nth second is Sn minus Sn minus 1. Now this you get it to be u plus a by 2 into 2n minus. You can do the simple mathematics and get it. This is the distance traveled in the nth second. And this is the, you get it in terms of initial and final velocity. The average velocity is half of that. So displacement is average velocity into time, right? So this is clear, student. Now let us move on to problem solving. So as I said, the main part of this studying motion in a straight line lies in not so much of concepts there, but problem solving. So, if you like this, students, please subscribe to our channel and press bell for notifications, please. Okay, so let us begin with our examples. First example is this, student. The velocity of the particle is v is equal to v naught. So it is given as a function of time, and you see it is changing with respect to time. Therefore, the particle is not moving with uniform velocity. Okay, if its position is x equal to 0 at t equal to 0, then its displacement after a unit time. So now what do you do, students? You cannot use the equations that you have derived for motion with constant acceleration, because this is again not constant acceleration. So in such problems, students, so such general problems, how do? You have to take the help of calculus. Okay, be careful. There are many problems you get in your exams like this. Okay, so this what you have to do is dx by dt, since this is just traveling along the x-axis, let us say. So this is v naught plus gt plus ft square. And you can integrate both the sides. So you must know the formulas for integration. And then you can put the constant of integration also. Okay, plus c. But it is given that x is 0 at t equal to 0. So c becomes 0. Right? So the initial condition gives you the value of c. Now you want x at t equal to 1. X at t equal to 1. So that is v naught plus g by 2 plus f by 3. So did you get this, students, this answer? So what is this? This is C option is correct. So what I mean to say is you need to approach such problems with the help of the definition and the calculus formulas. These two things must be clear to you. Let us see some more questions, students, like this. Now, a particle located at x equal to 0 and t equal to 0 starts moving along. So at t equal to 0, at time t equal to 0, it is at origin and it starts moving. So u is also 0. Okay, in positive x direction with a velocity that varies. So the velocity now is a function of displacement as alpha x, root x. The displacement of the particle varies with time. So you need x as a function of time, students. So again you can do this very easily. So dx by dt is alpha x. So you are making use of this definition of velocity for one dimension, right? Dx by dt is v, right? Now what you do is you integrate, bring the variables, like variables to one side, and then integrate both the sides, and also use the limit of integration. So at t equal to 0, x is 0, right? And at t equal to t, you don't know what is x is a function of time you want, right? So the integration formula now you'll have to use, students. For this, 2 root x is alpha t, right? And if you substitute the limit, you get this only. So what you get, x is proportional to t square. If you square both the sides, squaring both the sides, right, students? So what is the answer? The answer is A option. I hope that is clear to you, students. Next question. Now let us do this specific question. So two questions. We took the help of calculus and also the formulas, right? Now, an automobile traveling with a speed of 60 kilometers an hour can brake to stop with a distance of 20 meters. If the car is going twice as fast as 120 kilometers an hour, the stopping distance will be. So you need to find the stopping distance for such an instant. Now see, students, now over here you have to assume that the automobile is retarding at a constant rate. Okay. So this is a specific example of motion with a constant retardation. Motion with constant retardation. So you are having this final velocity is 0. Initial velocity, let us write it in this 60 kilometers per hour. So be careful, I am just neglecting the unit, but it is kilometers per hour. And I am not converting it. I'll tell you why. I am not converting it to meters per second. Okay, 2a and this is 20. And if the car is moving with twice the speed, that is 120, then retardation is same, students. You need to find the stopping distance. So basically, I have not written the units. They are incompatible in this equation. You have to be very careful. You need to make sure that when you're writing equations, the units are also taken into account. But over here, I am ignoring that purposefully, student, because the solution does not demand it. There is no use of it, because if I take the ratio, anyway, units will get cancelled. So I take the ratio of this, student, so it becomes 1 by 4 is 20 by s. So s is 80 meters. So the stopping distance will be 80 meters. So this was a particularly simple example of motion with constant retardation. You just had to figure that out because you are using the same brake, students. So that if you are using the same brake, then the retardation, the force is same, so the retardation is same, right? Is that clear to you? Now we can do one more question, students. A car starting from rest. Again, this is a very specific example of motion with constant acceleration. So keep in mind, students, in this chapter, motion in a straight line, either you get a general problem wherein it is not a specific case wherein you can use formulas. You need to proceed using calculus. This is one thing. The second thing is, as soon as you figure out that this is a motion with constant acceleration, like in previous question, you had to figure out yourself. But over here in this question, it is given that it is a motion with constant acceleration for certain instant of time, and for certain instant of time it is motion with constant speed, and that's much simpler. Motion with constant speed is much simpler. So when you get to know this, then you can use the formulas. Don't use it otherwise, right? I need to make sure that in this chapter, you just need to make these two things very clear in your mind. And if you are clear with the students, you will do these problems easily. So a car starting from rest accelerates at the rate f through distance s, then continues at constant. So you know what will be the velocity at the end of that distance? V square minus u square is 2fs. So you know it will achieve a velocity of speed of under root 2fs, right? This is one thing. And then it moves with this speed. So it moves with this speed for, so under root 2fs for time t. This is the second part of the journey. First part is the acceleration part. Second part is the constant part. Third part is the retardation part. So it will come to speed 1 minute, students. Yeah, it comes to rest. So 0 square minus v square. So this is the speed, and 2 f by 2 into s prime, right? So this is the retardation. So s prime, how much distance it travels? Let us see, students. It will be retardation. So minus sign, and this minus gets cancelled. So 2f, right? Because this 2 and this 2 will get cancelled, and 2s, sorry, not 2f, 2s. So what I mean to say, students, is this is, it covers s, this it covers 2s, and the total is given to us in the question that it covers a total distance of 15s. So it covers a distance of 15s minus s plus 2s with constant speed, right? That is 12s, right? I hope that is clear. Yeah. Now 12s it covers with distance speed with constant speed. So you need a relationship between s, f, and t. So you can write 12s is equal to, this is the constant speed into time, right? So this you can square it both the sides, students. What will you get? So you will get 144 s by f. This is t square over here. So s is equal to, yeah, but there is another 2 will get cancelled. 2 will also come, students, over here. So that will, so you get the relation s is equal to 1 by 72 ft square. I hope that is clear, students. So you have to just figure out the relationship between distance, acceleration, and time. So it was a combination of motion with acceleration, traveling with constant speed, and then deceleration. I hope this is clear, students. How do you solve this? So in such problems, you just directly use the formulas that you have derived. You need not, go into the derivation and all that. So I hope these two different types of problems that we have covered today is clear. We will take another session on this, and we will, go into much more mm, involved questions that have been given to you in your examinations. All these are examination questions, students, so that you get a feel of what is being asked in the examination. We have purposefully selected only those questions, right? Is that clear? So thank you, students, for watching it. Please like, share, and comment, and subscribe to our channel. Thank you, students.